Hello good dear viewers. In this tutorial we are going to find a solution to this nice Olympiad mathematics question. We are given that if x squared plus 6 minus root 3 multiplied by x plus 10 minus 3 root 3 is equal to 0, we are asked to evaluate x plus 3 to the power of 17 plus 1 divided by x plus 3 to the power of 17. Alright, let's get started. I would like to start from the first equation as always. So here is our first equation. I would like to transform it in terms of this expression. So let's get started. To the left hand side we have x squared, then plus I would like to distribute this x inside. We have 6x minus root 3x, then we have plus 10 minus 3 root 3. The whole of this is equal to 0. Now I would like to bring 3 times this, and this together because we are going to form a perfect square quadratic expression. So we have x squared plus 6x. Then I would like to write 10 as what? 9 plus 1. 9 plus 1. Why? Because we know that half of 6 is 3 and 3 squared is 9. So from here we have a perfect squared quadratic expression. We still have this and this together. So we have minus root 3x minus 3 root 3. The whole of this is equal to 0. So let's factorize this. You take x plus half of the coefficient of x, 6 divided by 2 is 3, all to the power of 2. Then we have plus 1 here, and I would like to factor out negative root 3 here because you can see we have it in common. So we have minus root 3. Then inside we have x plus 3. The whole of this equal to 0. Now I would like to let x plus 3 to be equal to something else. Can we let it to be equal to p? Let's do that. Let x plus 3 be equal to p so that we have p to the power of 2 plus 1 minus root 3 p. The whole of this is equal to 0. Since we know that p is not equal to 0, we can divide both sides by p. Let's do that. If you divide p squared by p, you have p plus 1 divided by p, then minus root 3. Because if you divide that by p, you have only minus root 3. The whole of this equal to 0. Now let us take minus root 3 to the right hand side. So we have p plus 1 divided by p equal to positive root 3. Now I would like to cube both sides. P plus 1 divided by p all to the power of 3. This is equal to root 3 to the power of 3. But remember this binomial expansion. If you have a plus b to the power of 3, this is the same thing as a to the power of 3 plus b to the power of 3 plus 3ab multiplied by a plus b. We are going to apply the same thing here where our a is p and b is 1 divided by p. Therefore, to the left hand side, if expanded to the power of 3, we have a to the power of 3, which is the same thing as p to the power of 3, plus 1 divided by p to the power of 3, plus 3 multiplied by ab. This is a, this is b. If you multiply them together, you have 1. 1 times 3 is still 3, right? Then inside, you have what? A plus b, which is the same thing as p plus 1 divided by p, right? And what about the right hand side? It is the same thing as 3 root 3. Why? Because root 3 to the power of 3 is the same thing as root 3 times root 3 times root 3. These two will give us root 9, and root 9 is 3. So we have 3 root 3. But remember that P plus 1 divided by P is nothing but root 3 from here. So we can substitute it back. So we have P to the power of 3 plus 1 divided by P to the power of 3 plus 3 multiplied by root 3, right? And this is equal to 3 root 3. So if you take this one to the right hand side, it is going to become negative, and you have 3 root 3 minus 3 root 3, which is equal to 0, right? Therefore, P to the power of 3 plus 1 divided by P to the power of 3 is nothing but 0. So now let us multiply every single term by P to the power of 3, because I want to eliminate this fraction right here. So by doing so, you have P to the power of 3 times P to the power of 3, which is P to the power of 6, plus 1, because P to the power of 3 multiplied by 1 divided by P to the power of 3 is 1. This is equal to what? 0 times P to the power of 3, which is still 0. Take this one to the right hand side, it becomes negative. Therefore, P to the power of 6 is equal to what? Negative 1. Let me close this one, very important. Now, what about the expression we want to evaluate? Which is this one. Let me just copy that. This is the expression we wish to evaluate, but remember, I have let what? X plus 3 to be equal to P right from here. Look at it here. I have let X plus 3 to be equal to P. Therefore, what do we have here? We have this to be equal to P to the power of 17, right? Plus 1 divided by P to the power of 17. But we have seen that P to the power of 6 is equal to negative 1. So why can't we express 17 in terms of 18? Because we know that 18 is a factor of 6, right? So we can multiply the top and the bottom by P divided by P, right? So we multiply the whole of this by P divided by P, which is the same thing as 1. We have not changed anything. So this is what? P to the power of 18 divided by P plus what? P divided by what? P to the power of 18, which is equal to, we know that P to the power of 18 is the same thing as P to the power of 6 to the power of 3, right? So this is P to the power of 6 all raised to the power of 3, because 3 times 6 is 18. We divide this by P. We add it to what? P divided by P to the power of 6 all to the power of 3. So this is equal to, we know that P to the power of 6 is negative 1 according to this equation. So we are going to substitute negative 1 to the power of 3 divided by P, then plus P divided by negative 1 to the power of 3. We know that negative 1 to the power of 3 is still negative 1. So this is equal to negative 1 divided by P. This is also negative 1. So we have negative P here, because P divided by negative 1 is negative P. We can factor out negative 1, right? So we bring negative 1 at the back. Then inside, we have 1 divided by P plus P, right? But we have seen that 1 divided by P plus P is equal to root 3, since from here, can we find it? Look at it here. Is equal to root 3. So we substitute it with root 3. This is equal to negative 1 multiplied by root 3, which is what? Equal to negative root 3, which implies that the whole of that expression that we are looking for is equal to negative root 3. The whole of this is equal to negative root 3, provided that this equation is true. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.